Hi, Mr. McBrien. This is TEJ20, storing information. So something fun from the news a few years ago. Storing information is something that used to be dedicated to the inside of our computer cabinet. And nowadays we start to think in terms of data centers and large facilities worth billions of dollars that store information in a central form. Something for us to think about looking forward. Today we're going to focus more on how a given bit is stored and less on the business of this aspect. So yesterday we did a little overview of the computer. Today we're going to talk about storage. We're going to talk about how we contain the information that a computer needs. So the basic idea of a hard drive is that we store information in a non-volatile way. In other words, we don't need power to retain that information, and we store it in magnetic. And we store the information magnetically. So each bit, each 0 or 1 that we store is stored as the orientation of a magnet on a specific physical part of a disk. When we write to the disk, we use a strong magnetic field to align the magnetic material in that small location. When we go to read that information, we simply check to see what the orientation of that material is. Again, in that physical location. So the reading process itself is based on the force that a permanent magnet experiences while it moves over that location on the disk. And we can actually look at a graph of the force as a function of the geographic location. So in this case, the color from blue to red looks at repulsion versus attraction of our permanent magnet as it moves across a given location on the disk. And so this is a very interesting idea, not because that concept is that difficult, but because of the dimensions involved. 0.004 millimeters we can store, in this case, 1, 2, 3, 4, 5, 6 bits across 0.004 millimeters. So we have extremely dense packing of these bits in terms of these tiny magnets. Now the idea is not particularly new. The idea of magnetically storing information dates back more than a century now, but hard drives themselves are relatively new inventions. So, whereas we were storing information on tapes back to 1928, the hard drive, the idea of this disk that spins, was invented in 1954 by IBM. And the hard drive was about the size of a refrigerator. It weighed about a ton, cost about $500,000 in today's terms, but it had this massive storage capacity of 5 megabytes, unheard of density of containing information. And the idea was a good one. So, while the number of hard drive units shipping is declining a little bit, we are still producing more bytes in hard drives each year. What is this? More than half a century later. So there's lots of inventions that have become popular and declined in that time frame. And hard drives still remain extremely important. So let's open one up, shall we? If we open up the hard drive, almost all of them will look a lot like this. So inside the case, which you'll notice if you tear one open yourself, if you have an old one you can open up, you'll see that there's a rubber gasket to keep the dust out. And then inside this extremely clean device, we see a series of these discs. In this case, there are 3 platters. We see the actuator arm and the head that moves across it. Now, there's one of these heads for each one of these platters, so it's threefold in this case, 3 different heads, and a spindle. And this thing will spin extremely quickly, thousands of times per minute. So if we move to a simpler picture for a second, we can look at some of the things that are physical, that we can see, and some of the things we can't. So here's our actuator again with the read-write heads. Again, 3 platters. But now we have superimposed a graphic where we talk about a track, that's a circle all the way around, a sector, an individual location for data, and a cluster, a set of sectors. And we'll return to this concept again later when we talk about disk management techniques. Hard drives have specific kinds of connectors. So if you're going to buy a hard drive, you make sure that you've got the right connections in your computer. So the old style hard drives had IDE connections, and then in the center we have a SCSI connector, and then we have SATA down below. So you need to be able to recognize these kinds of connections here. Notice all of these hard drives, this ancient one here, a fairly old SCSI hard drive here, and our relatively modern hard drive, they all have the same kind of power connection. They need power in order to spin at those fast rates. Now, we can look at how data is organized on a given hard drive. We need to look at it from 2 different perspectives. First off is the idea of partitioning. So some of you may have worked with a computer that had 2 or more partitions, and you'll see D drives and E drives and Z drives and these kinds of things. We can partition a hard drive into different sets, and this helps with data organization. But our different partitions can have different file formats such that we can have a different operating system on different parts of the same hard drive. And if you set up your computer for dual boot, you'll use that trick in order to do this. There are various utilities that will partition our hard drives how we want them to. The good news is our Linux installation that we use in our class automatically puts a partition onto the hard drive to give itself a location compatible with the Linux operating system. Now, the file systems that we use, the way that we divide sectors into locations, these file systems are extremely important. They're essentially a logic for turning a sector into a location on a hard drive. Classically, we had FAT, file allocation table, and this evolved over the years to support larger and larger hard drives for the most part. So we had FAT16, 16-bit, 32-bit, and FAT32 was nice because it would support up to 2 terabytes, and who would ever need a bigger hard drive than that? In fact, many people, and so NTFS was invented in order to address even more space, and really you can pretty much just use NTFS when the system asks you what kind of file system you want to use. If you've got a Windows build, you can use NTFS. So the other operating systems, Mac has their own APFS. Androids and PCs will use NTFS, and Linux has a whole bunch of different options for their own file system. This is part of why we need our own partition for Linux. Now, hard drives have some limitations. Obviously, they're fantastic technology. They've been around for 70 years or so. There are billions of these things in use today. However, there are some downsides to storing your data on hard drive. Now, those moving parts, that actuator arm that has to move around to get to given sectors on your platter, it's a moving part. The platter itself is spinning. Anytime you have the moving parts, you have a lifetime that is not infinite. They won't last forever. In addition, those magnetic sectors will wear out, so they can be destroyed. There's a separate limitation that has nothing to do with wear and tear. It has to do with simple logic. The actuator arm can only be in one place at a given time. This means that we can only read and write from a single spot on the hard drive at any given time. And so it takes time to read and write from a hard drive. So, if we want to criticize this tremendous innovation, hard drives are large, they're heavy, they're fragile, and they're slow. However, there's good news. So there are other ways to store information, and one of these is RAM. Now, RAM is different from a hard drive. It's volatile, solid-state memory. So almost every aspect of this is different from a hard drive. So when we store data on RAM, we don't store it on a spinning disk. We don't need an actuator arm. But it's temporary storage. So this solid-state memory system doesn't need to spin up. It doesn't need to spin a disk. It doesn't need to retrieve from individual sectors at individual times. It is much faster to access than a hard drive is. Why don't we just use RAM? Well, there's two reasons. The first is that volatile designation. When you turn off the power in your computer, all the data in the RAM is lost. The second is that it is more expensive to store things on a hard drive. Less expensive to store things on a hard drive than in RAM. Having said that, RAM is getting inexpensive. It is computers now can be equipped with a great deal of RAM relatively inexpensively. And so we beef up the RAM and we have lots more quickly accessible temporary memory. Things we know we're going to need immediately, we can load it into RAM and have extremely fast access to it. So if you use a lot of applications at once, you're going to want a lot of RAM. In fact, with modern computer users, we do tend to use a lot of applications at a given time. And so the average user will see a good improvement in performance by increasing the amount of RAM in a given computer. Now, there are other ways to store data in a solid state form. So you may have heard of SSDs. Well, SSDs have some of the advantages of RAM, but are non-volatile storage. So when we turn off the power, the SSD retains what it has available. So this is a good compromise between the volatile RAM and the non-volatile slow hard drive. Why? Because our operating system, we don't want our operating system to have to be reinstalled every time we shut down the computer. We need it to be in non-volatile storage, and this is a good place to put our operating system. When we boot up the computer, we don't have to wait for all that information to be loaded from a hard drive. It can be loaded from the SSD. Now, if we have other applications that we use a great deal, we might also put those on the SSD as well to improve the performance of the computer. And the SSD has the advantage of being more durable than a hard drive. It also uses less power because it doesn't have to spin that disk at an extremely fast rate. On the downside, SSDs aren't designed to be rewritten many, many times over and will wear out eventually from the perspective of constant rewriting. So we put things on it that we want to stay on it for long periods of time. And there's more good news. Moore's law seems to be applying to solid state drives. They seem to be getting larger and cheaper every single day. Now we can ask ourselves, are SSDs hard drives? It's a fun debate to have in some ways if you're as geeky as I am. So we can argue that an SSD is a hard drive because it's non-volatile storage. We can argue that it's a hard drive because it's rewritable. We can argue that it's a hard drive because it contains our OS. However, hard drives are magnetic storage and SSDs are flash memory. So in that sense, they're not. They also aren't disks. So if we open one up, we see a whole bunch of integrated circuits. We don't see a spinning platter. So we can talk about then SSDs versus hard drives from another perspective, and that's in terms of speed. What kind of advantage do we get for spending the money on an SSD? Well, one report online identified that Windows 7 takes about 22 seconds to load from a solid state drive, about double that to load from a modern hard drive. So if that 20 seconds is important to you, then you might want to invest in an SSD. In terms of reading the data, we see a similar improvement, about a 3 times to 10 times improvement depending. So again, if you're loading a specific file many times, you might want to store it on an SSD to have quicker access to it. And yes, what is it, about a 3.5 times improvement in loading a large Excel file. Now, don't think that an SSD is RAM. RAM is still thousands of times faster than an SSD for various reasons. So you can't, if you're looking at upgrading your computer, you should probably start with the RAM. And then if you're still not satisfied, then think about an SSD. Okay, we've alluded to durability a couple of times. It is worth thinking about the idea that regardless of the kind of non-volatile storage you use, devices fail. And so backups are a critical aspect of safe computing, and we'll return to these at the end of the unit as well to talk about them in more detail. But the short lifetime of a hard drive, roughly 5 years, can be expected to be obtained from a hard drive. It doesn't need to be too much of a concern as long as we take advantage of additional things that are available to the modern computer user, particularly cloud storage and network drives, can allow us to back things up in an automated fashion. Now, when we go to dispose of a given computer, we need to think about what a hard drive is. That non-volatile storage that was so exciting when we were talking about storing our operating system, that non-volatile storage becomes a detriment. So a large amount of information can be left on a hard drive. Even after you reformat that hard drive, it can be retrieved with certain utilities. Now, Windows and Mac and Linux all have utilities that will write random ones and zeros to empty spaces on a hard drive to ensure that files are very difficult to retrieve after a hard drive is disposed of. You can accomplish much the same thing if you just take some very large files and write them to all the unused locations on the hard drive. Once they've overwritten it, it's essentially impossible to retrieve any sensitive information that might be there. Now, having said that, many accounts suggest that the only true way to destroy information on a hard drive is to destroy that hard drive. And so, if you're a member of the CIA, you may want to consider simply dissolving your hard drive in acid to make sure that no one can ever get any of the information about the spies off of that hard drive. There are other ways to store information. So optical drives, while they're not as exciting as they used to be, are still an important way to retain information. Optical drives use lasers to read bits from the surface of CDs and DVDs based on the concept of pits and lands. So, mass-produced CDs and DVDs use layers of material, acrylic and aluminum, in order to have extremely small depressions on the disc, which then represent ones and zeros. We can also write to them. So mass-produced ones, of course, the surface is aluminum, as we alluded to in the last slide. However, we can have writable discs, and these use a layer of dye inside the disc. So you have a layer of reflective aluminum, a layer of dye, and then some plastic. And the laser goes in and burns dye spots to represent zeros. The unburned areas represent ones. So that's a writable disk. What about rewritable disks? Once we burned that dye, it's permanently burned. There's nothing we can do about that. So how do rewritable CDs work? Well, in fact, instead of using a dye, they use a crystalline material. So crystalline, you can think of it as being like a sugar cube, like a crystal of sugar. And so that pressed material between the waterproof plastic layers and the aluminum, that material, when it's crystalline, allows the light through, but when it's called amorphous, so like a gel, it stops the light from reflecting, and that represents a zero. So those read-write disks don't use a dye at all, and instead translate between crystal and amorphous. And the good news is that process is reversible. So we can take the high-power laser and make the crystal amorphous. We can take a low-power laser and allow it to go back to crystalline form. And that disk will support this exercise multiple times over. So we can rewrite that optical disk. Now, what are the advantages of optical? They're extremely durable, they're waterproof, and they're cheap. So these are fantastic attributes for these disks. And of course, we can make them write protected if we want to. Okay, so key points then from today. Hard drives are critical for computers because they provide large amounts of storage in a non-volatile way. So we can store our operating system on the hard drives and know that that OS will be there the next time we plug in the computer. Now, the limitations of hard drives are one of the key things that makes computers less efficient today, and we have other forms of storage to make up for this, such as RAM and SSDs. And so if we understand what the advantages are of the different kinds of storage, we can configure a computer that reduces the effect of the weaknesses on the user experience. So we can design a computer to match the user's requirements. So for your homework today then, please work on the storage questions and then complete the page 1 of the internal hardware sheet from yesterday. Thanks very much. Have a great night.